Now, we want to look at a singular matrix. So what is a singular matrix? Let us attempt to get the determinant of this matrix. The determinant is the product of elements in the leading diagonal, that is 4 times 3, minus product of elements in the other diagonal, that is 2 times 6, and that is 12 minus 12, which gives us 0. If we check this, the product of elements in the leading diagonal, that is 3 times 8, minus product of elements in the other diagonal, that is 6 times 4, and that is 24 minus 24, and that is 0. Therefore, a matrix whose determinant is 0 is what we call a singular matrix. So it is a matrix whose determinant is 0. Now, such matrices have no inverse. They have no inverse. So singular matrix have no inverse. Singular matrix has no inverse. So if a matrix is singular, you cannot get its inverse, because inverse is 1 over the determinant. When the determinant is 0, then division by 0 is infinite, so you cannot get that number. Therefore, this matrix does not have an inverse. But the knowledge of a singular matrix can be set this way. Find the value of the unknown if the following matrix is singular. For example, we have that is 4, 3, 5, C is singular, and the other one is 4 y squared 4 y. So we are given such like matrices to find the value of the unknown. The unknown here is C. So you're told that this is a singular matrix. So if this matrix, let me call it X and call this matrix Y. If this matrix X is singular, then it means that the product of elements in the leading diagonal, that is 4 times C, which is 4C, minus product of elements in the other diagonal, which is 15, should give us 0. If it is singular, then its determinant is 0. And therefore, that one means that C is equal to 15 over 4, and that is 3 and 3 quarters. That is 3 and 3 over 4. That will be the value of C. That is the value of the unknown. Here we are told that this matrix is singular. If it is singular, therefore, the product of elements in the leading diagonal, that is 4 times y, which is 4y, minus elements, product of elements in the other diagonal, which is 4 times y squared, should be equal to 0. And therefore, we see that y is common here, y is common here, and therefore 4y is common into 1 minus y is equal to 0. So if we multiply two numbers and we get 0, then either 4y is equal to 0, implying that y is equal to 0, or 1 minus y is equal to 0, and y is equal to 1. So these are the values of y that will satisfy this equation. Either y is 0 or y is 1. So that is how we now apply the knowledge of a singular matrix in solving mathematical problems. Thank you.